this doesn't give us the equality statement we said we needed. Okay, when I was talking about this earlier, I said you always have to have an equality statement. Okay, and we said 1 mole of any substance equals the sum of all the atomic masses of all the atoms in the formula written in units of grams. All right, well, here's our grams, and this is grams of carbon dioxide, and what's that going to equal? It's going to equal 1 mole of that carbon dioxide. Now we have an equality statement. It's called a mole because the guy who thought up the whole thing called it a mole. Mole is Latin for heap or pile, and that the spelling in German and in Latin is MOL, and the guy was German. So
when we're writing it, like in the formula, like we put MOL.
you can put MOL. You don't have to. You can get E on the end. The E on the end is the English spelling. That's fine either way. Okay. All right, folks, turn down the volume and give me your attention. Okay. So now we have an equality statement. James, here's your equality statement to build that conversion unit. Okay. So what part of this equality statement am I going to put on the bottom here? Nope. I need to have what matches the units and species on the bottom. Okay, 44.0095 grams of carbon dioxide has to go on the bottom. Okay? Manuel, what's going to go on the top? Somebody tell him that? Okay, 1 mole of CO2. That's the other side of the equality statement. It goes on the top. Okay?
Hey, but wait.
Yes.
They all got the species of CO2.
They do. They do. You're right. It will cancel out. Okay, hold on. Robbie, what do I do next? What do I do next? Folks, you are being distracting. Okay? I take that really seriously. Okay? All right. Hold on. Let Robbie think it through just a minute. Okay? What do I do next, Robbie?
I think the best option would be to multiply the top, which is 4.25.
Mm-hmm.
The 44.0045.
Well, this is, you're going to divide this number by that number. This is division. But there's something we need to do before we even do that. Sierra?
Cancel your units. Thanks, Rodney.
Cancel the units. Cancel the species. Okay?
You don't cancel out the CO2 because it doesn't have the grader in front of it.
You can cancel the CO2 because they got one up here and one down here. No, we don't cancel that. There's nothing to cancel. There's no moles of CO2 on the bottom. I can't cancel that. Okay? All right. Now we're ready to do the math. I do the math that Robbie was talking about. This number divided by that number. This number divided by that number, because this is on the top and this is on the bottom. Please put that in your calculator and get an answer. Let's practice with your calculator.
0.096570005.
Folks, all right, look. I'm tired of asking you to be quiet. Okay? I don't mind you helping each other, but do it in a whisper. I want you to help each other. Just do it in a whisper. If you're talking about other things, stop. Let's focus on chemistry. All right. All right, Reese, what'd you get again? 0.0? Is that right? 95? Whoa, slow down. 9657. Can we just wait till I finish writing it down? Just hold on a second. 005874. 4. Okay. So maybe you need to check your math. In fact, it is a really good idea. Is everybody listening? It is a really good idea. I can't emphasize strongly enough that you should double check your math in your calculator every time. Yes.
Can you tell me what he did? Like,
He took this number, hit his divide button, and put in that number, and hit equals. Yes, Scott.
Like on the test, different sections for these kind of problems and for the first kind of like how do we know when to put
I got
the
it.
6.02 to the 23?
That's a good question. You know by what the problem asks you for.
Yeah, my family was.
You know when to do this as opposed to the other process by what the problem asks you for. Yes.
Would it be okay to put like 9.657005874 times 10 to the negative 2 times?
Yeah. The same number. What you just gave me was scientific notation. Same number, just written in a different way. It's perfectly okay.
So
Okay.
the answer would have to include the times. Yeah.
If you're going to do that, yes. If you have 9.657005874 times 10 to the negative 2, you can't leave off 10 to the negative 2. It's just division, folks. You just have to put in this number divided by that number. That's it.
We understand. We just did our killing today.
Okay? Okay, you need to show her what you're doing too, okay?
She got it. It's just her calculator put .096570059.
It's okay.
It rounded it off.
Yeah, well, no. Listen. Her calculator, listen. Guys, listen. Her calculator just doesn't have as many digits over here. That's all.
But it rounded it off. Said 5 8. It's got 5 9.
That's what it should do. If it doesn't have as many digits on the display, it should round it off. All right. What are we going to do with that number now?
Put the carbon dioxide.
You got to have the moles of carbon dioxide over here. Now what?
Me too.
You got the rest of the digits except for the last 3 digits, so you have 0.096.
How many digits do I need in the final answer?
3.
3. Leading zeros are never significant. That's our first significant digit. 1, 2, 3, we round off from here. Oh, I'm sorry, I misunderstood you. Okay. So 0.0966 moles of carbon dioxide.
How would you do it, Marlon? Would it be 9.657?
No, yours would be 9.66 times 10 to the negative 2. Still got to have 3 digits. Okay. Let's change this to moles. All right, here's another problem for you. So if you will, let's solve that problem. You're using the same process. You're going from grams to moles or moles to grams. You've got to have a molar mass calculation. And you should have an equality statement when you finish. Okay, when you get done calculating your molar mass, you must have an equality statement to build the conversion unit.